Okay, good afternoon, everyone. Really appreciate the invitation and the chance to be here. I really wish I were over there with, it would have been nice to have done this event in person because there's obviously lots that we would like to talk about more informally, but it's great to see everybody in this venue. So, emergence is a contested concept. At its best, it's an amiable jumble, and at its worst, it's an intractable mess. But the word emergence is evocative, and the concept is appealed to by scientists and philosophers alike. It makes its way into the textbook tradition, and I don't think we can just leave it aside. I'm a pluralist, and I am disinclined to argue that some one conceptual specification of what emergence is will be the right one. So what I want to do today is to provide some tools to classify the kinds of phenomena we call emergent. And I want to do that in a somewhat different way than others have attempted. I shall not distinguish strong or weak emergence or ontological or epistemic or use any of the other distinctions most commonly offered. My thought instead is that when we count some phenomena as emergent, there is some mechanism that makes it emergent. If we can put some order on the kinds of emergence generating mechanisms, we can use it to clarify the kinds of emergence. If there's any unity to be found in our concepts of emergence, it's through Emergentist slogans. So I want to discuss two and consider their implications. First, emergence occurs when the whole is more than the sum of its parts. This is an image of composition of things or of substances. Second, emergence is a source of novelty. Something new emerges from what now is. This seems to me to be the pre-philosophical sense of emergence, the sense in which butterflies emerge from their cocoons or seedlings from the earth. These slogans are distinguished by their temporal valences. The first is synchronic. The emergent space and what emerges from it co-occur, while the second is diachronic and causal. The emergent space produces something new over time. Sometimes we see an attempt to distinguish metaphysical from scientific senses of emergence, and there's a temptation to see the first slogan as the metaphysical one and the second as the scientific one. Indeed, these slogans seem roughly to pick out what Bechtel and Winning recently called the distinction between being emergence, which is the metaphysician's concept, and pattern emergence, which is the scientist. But I actually think both of these varieties of emergence have scientific import. So emergence is often opposed to mechanism. Originally, the context of its introduction to the philosophy debate comes from C.D. Broad, who introduced it as an alternative to mechanism in the context of the mechanism vitalism debate in the 1920s. And emergence is also traditionally opposed to reductionism. Reductionism is supposed to show that higher level phenomena are nothing but arrangements of lower level phenomena. But Bill Wimsatt suggests another way, which is that reductive accounts allow us to understand mechanisms of emergence. And it's Bill's ideas that have motivated me a lot in this talk. So here's a quotation from a paper of Bill's called Emergence as Non-Aggregativity. This is from 2007. He says, a reductive explanation of a behavior or a property of a system is one that shows it to be mechanistically explicable in terms of the properties of and interactions among the parts of the system. Emergence of a system property relative to the properties of the parts of the system indicates its dependence on mode of organization. So, as I said, Bill is inspiring me here, and this is an important elaboration of the more than the sum of the parts slogan. But a fuller picture of organization will be needed, especially with a diachronic sense of emergence, since it isn't easy to conceive of this kind of emergence as emergence of a system property. So here's the roadmap for the talk. I'm going to start with a bit about mechanistic ontology and suggest how the concept of mechanism will give us new resources for talking about what there is and what emerges. And then I will use the concept of mechanism in order to spell out a account of varieties of mechanisms and how that maps to varieties of emergence. And then at the end, I'll come back to the worry that maybe what I'm talking about isn't really emergence, that I'm really being too reductive and that I haven't really gotten to the concept at hand. All right, thank you for the mechanical duck and the poster. I love the mechanical duck, and I thought I would use it as an image here. So to get a grip on the nature of emergence, we must be able to say what emerges from what. And to do that, we must say something about what there is. That is, we have to say something about ontology. One of the chief advantages of new mechanism is that it offers an ontological toolbox that's somewhat different from the one given to us from analytic metaphysics, and one that I think is entirely more suited to discussing emergent phenomena. I can express my worry about the tools of analytic metaphysics in terms of something that some of you may know as Maslow's Law. This is the law that says that if you have a hammer, everything looks like a nail. And there is something I call Yagwon Kim's corollary to Maslow's Law, which is if you represent the world with modal predicate logic, emergence will look like a modal relation between properties. But I want to take a different approach. And so let's talk about mechanisms. So to start our discussion of that ontology, let's look at this definition. This is the one that comes from my book, minimal mechanism, I call it, that a mechanism for a phenomena consists of entities or parts whose activities and interactions are organized so as to be responsible for the phenomenon. Most of you know that there have been a lot of attempts to offer a definition of mechanism, and this one is an amalgam of accounts that represent something of a consensus that has emerged over several decades. I call this minimal mechanism because it's thin and permissive, and it seems to capture in its net a wide range of things that scientists have called mechanism. Nonetheless, it does have some important consequences. First, mechanisms are composites consisting of entities acting and interacting. Second, mechanisms are at their core processual. They are activities or interactions, doings or happenings. And that means that mechanisms are ultimately not things. While the term mechanism is sometimes used to refer to composite entities or systems, in the proprietary sense that I'm going to use it, which I think is the most important scientific sense, an entity like a clock or a cell is not a mechanism, but the entities acting, the clock's ticking or the cell's signaling, for instance, is. So, it's perfectly reasonable for people to call these entities that act mechanisms too, but for the sake of clarifying this distinction, I'll call them mechanistic systems. So, at the heart of this ontology is this dualism between entities and activities. So entities are also called parts, components, objects, structures, systems. And the crucial sort of metaphysical feature of them is their continuance. They persist and endure through time. Activities, including interactions, are also called processes or observations, and by my light, events are also in this category. And they are occurrence. They have temporal parts or stages. And activities generally are mechanism dependent in a way that I'll try to clarify. So let me say a little bit more about this distinction. While everybody who has talked about mechanisms in the last 30 years, or most everybody, seems to recognize some version of these two things, the specific terms and the moniker of dualism are due to Machamer, Darden, and Craver. I'm grateful to Marie Kaiser and Beata Krickel for pointing out the connection between this dualism and the distinction between continuance and occurrence, which actually dates back to the logician W.E. Johnson. Within the metaphysics community, the dualism of continuance and occurrence is not widely accepted. For commonly, metaphysicians in the name of parsimony would hope to reduce one of these categories to the other. Perhaps you can tell such a reductive story, but what compels me to this dualism as a practical position is that it is not just a common sense distinction in language, but it is found just about everywhere in scientific theory and practice. When scientists describe mechanisms, they inevitably identify both entities or structures or parts and activities or interactions or processes or operations. And notice that entities and activities are essentially interlinked because actions and interactions require actors, and entities, to be the entities that they are, must be act or disposed to act. So it's essential in talking about this ontology that we talk about compositional or part-whole relations. And with our basic distinction between activities or occurrence and entities as continuance, we have correspondingly two different kinds of compositional relations. So we have this entity or mechanism composition, which is a relation between activities, interactions, processes, or operations, and their constituents, activities and interactions, processes, operations. And this is fundamentally the relationship that that Craver was trying to get to when he introduced the notion of mechanistic constitution. But there's another composition relation, the entity composition relation, which is the relation between an entity or a system or an object or a structure, and the various entity systems, object structures there as parts. I've recently written a paper on this that I call corporeal composition. I'll come back to that in a minute. So what does this have to do with the emergence question? Well, the traditional way to think about emergence amongst philosophers is via properties and supervenience. It's no accident to me that the main article in the Stanford Encyclopedia of Philosophy on Emergence is entitled Emergent Properties. It isn't that anyone denies, or that I'm denying, that there are entities that bear properties, but somehow entities seem to drop out of the discussion in the metaphysics literature. Somehow, too, the processes of emergence are generally ignored. It is forgotten that emergence takes time. Many of the things we call emergent are not in any obvious way properties. We discover emergent patterns of behavior like flocks of geese, or in crystal formation, or emergent dynamics, or even the emergence of an organism from the developmental process. The new mechanistic ontology is better accommodated to these notions of emergence. So what emerges generally are novel composites, composite entities that are non-aggregative, to use Wimsatt's term, composite processes that produce novel patterns of activity. And new properties do emerge, but these properties depend upon mechanisms within the property bearers that account for their dispositions. All right, with that sort of background on what mechanisms are, let's talk about the ways in which we can divide mechanisms into kinds and how that might impact our understanding of kinds of emergence. I think we can find some basis for this taxonomy by going back to that definition of minimal mechanism. Looking at the definition, we can pick out 4 identifying features of mechanisms and classify mechanisms by whether they are similar with respect to these features. Namely, the varieties of phenomena and responsibility relations, the varieties of entities, the varieties of activities, the varieties of organization. And in addition to these taxonomic dimensions, we can classify mechanisms by their origins or their etiology. How did the mechanisms come to be? The schema is helpful because it allows us to see how different kinds of mechanisms lead to different kinds of emergence, and also to see why some mechanisms produce emergent phenomena while others do not. So I'm going to go through this, these dimensions a little bit, and I want to first talk about the varieties of responsibility relations. There's lots of ways to carve these things up, but one way was proposed by Craver and Darden, and that is, this comes from their 2013 book, and that is distinguishing between producing, underlying, and sustaining mechanisms. In producing mechanisms, we have essentially causal chains of acting and interacting entities. If there's any emergence here, it is diachronic. Underlying mechanisms have been the focus of discussions of mechanistic emergence, where it seems that whatever this is in the top circle emerges from what is below. There are also these maintaining mechanisms, and what's maintaining mechanisms do is maintain stability. If they're, and you might say that that stability emerges, but if such a phenomenon is emergent at all, it's probably going to be because of the underlying mechanism which gives the system its capacities for homeostasis. So my focus here in talking about emergence is going to be on the underlying mechanism. So here we've got this picture again, the same one that Brigitte showed us yesterday. And in this representation, we imagine that a mechanism is an entity acting, an entity or system S that is engaged in some activity psi, and it is constituted of the various X's and their activities, including interactions, their phi-ings. And if S is a new kind of entity, a new kind of composite, and if psi is a new kind of activity, you might think that these are emergent because they are non-aggregative, and that they emerge from these activities and entities that constitute them. Now, there are various reasons why I don't like that picture. And one of the limitations of it is that it does not make explicit the fact that many of the activities in mechanisms are relational rather than monadic. That is, many activities are interactions. So when you use this language of SSign, it makes it sound like there's one thing that is engaging in an activity. And that's why I prefer a somewhat different kind of representation, like this one that comes from my book. So here you have a picture of psi as an interaction between two entities, S and T, mediated by their environment. The graphical representation of synaptic transmission, which is shown in the picture below it, is just an example of the kind of mechanism that this diagram abstractly represents. But both of these cases seem to fit within Craver and Darden's category of underlying relations. So when we have cases where mechanisms underlie their phenomena, we have a variety of emergence. In particular, compound entities S and T that act or interact are typically not mere aggregates of their constituents and meet Wimsatt's definition of non-aggregativity. So let me pause for a moment to advertise the problem, or to talk about what I think is a hole in the literature and advertise this paper of mine that's meant to address it. The large and complicated literature on the problem of mechanistic constitution has really been focused on the category of activities. Because if you see, when you talk about a mechanism as an entity acting, it's really the activity which is the mechanism. It's the clock's ticking rather than the clock, right? But how and when do a collection of and so the question is, how and when do a collection of these activities constitute a larger activity? But comparatively ignored in the mechanisms literature, though it's much discussed in the metaphysics literature, is the question of object or entity composition. How and when does a collection of entities constitute some larger composite entity? These questions cannot be tackled in isolation, since entities, in the sense needed to understand mechanisms, are identified by their activities and their dispositions, or their powers, if you like. My paper, Corporeal Composition, offers an account of this relationship that takes seriously the causal and mechanistic basis of entity composition. Roughly, it argues that for one entity to be a corporeal component of another, it must contribute to the composite's persistence or to the composite's characteristic behaviors and capacities. One need not accept my particular account, but if we are going to know how composite entities emerge, we're going to have some account of when some collections of entities compose a new entity. So to summarize, if we have a composite entity, S, that is composed of component entities, Xi, and the S is of a different kind than Xi, we can call that entity emergent. So consider as an example a cell membrane, which is composed of lipids and proteins, and is a kind of entity distinct from either lipids or proteins. It has organization and structure. It is not a mere pile of those things. And relatedly, when an entity or collection of entities engage in an activity, psi, in virtue of the underlying activities of the components, we can call this an emergent activity. So again, if we have active or passive transport across a membrane, this is a novel activity of a cell that cannot be engaged in by the membrane alone or by any of the constituents of the membrane. So switching to another dimension, let's talk about kinds of phenomena. You know, can we, if we try to parse different kinds of mechanisms by kinds of phenomena. And I want to offer a basic way of parsing these things. We can either look at what I call material similarities in the kinds of phenomena, or we can look at structural similarities. So one way to think about whether two mechanisms are of the same kind is to ask what kinds of things they make or what kinds of things they do. So if a mechanism creates the same kinds of products or produces the same kind of state changes from similar inputs or output conditions. So talking about coffee, coffee makers are things that make coffee out of water and coffee beans and with some heat and so on. But similarly, we could talk in nature of mechanisms of viral transmission, which are characterized by the fact that they are mechanisms which permit a virus to move from one host to another. But we can also talk about phenomena in terms of structural similarities, mechanisms that regardless of the entities involved produce similar patterns and dynamics. So we can talk about oscillators or attractors or randomizers or amplifiers. And it's in these patterns of mechanistic phenomena, I think, that we see some of the basic criteria for emergence. So when we characterize the structure of phenomena, the simplest way to do it is by thinking about functional relationships between input or startup conditions and termination conditions. But more generally, the phenomena of interest may be the temporal evolution of state variables describing the dynamics of components or aggregates of components in the system. And this leads to pattern emergence. So the operation of structurally similar mechanisms may over time create structurally similar patterns, and some of these patterns will be novel. And the mechanism startup conditions constitute the emergence base for a diachronic emergence of this kind of novelty. So the kinds of examples I have in mind are very familiar in some of the in some discussions of emergence. So you have these patterns like points of changing dynamics or bifurcations, chaotic behavior, attractors or stable oscillators, and then the emergence of stability of aggregates, stochastic behavior from deterministic mechanisms and deterministic behaviors from stochastic ensembles. Many of these things are the kinds of things that are discussed in the context of dynamical systems theory. All right, moving to another dimension. I know I'm moving very rapidly, but let's talk about kinds of organization. So there are many ways to characterize organization. One can, for instance, characterize the topology of a component of a mechanism organization, as it happens when we look at network structure at the degree of modularity, or whether activities are organized serially or in parallel, for instance. One can also look at the kinds of functional dependencies that hold between components, for instance, whether they are linear or not. But I want to focus on two very general ways in which we can parse kinds of organization that are relevant to some discussions of varieties of emergence. And the first distinction is between what I'm going to call affinitive and induced organization. When a mechanism has induced organization, an exogenous agent or controller orchestrates the arrangement of the entities and activities that constitute the mechanism. Whereas in affinitive organizations, dispositional affinities are sufficient to order and arrange entities and their activities without exogenous control. So think of two ways to organize guests to the dinner party. In the first case, you have assigned seating and the controller, the host, has told people where to sit, and that is going to inform the kind of phenomena that occurs, the kind of interactions at the dinner party. Whereas in the second case, you simply allow the dispositional affinities of the guests and the constraints provided by where the chairs are and so forth to allow the party to self-organize. So here's the second distinction between what I call nuanced and minimal organization. In nuanced organization, a mechanism can only produce, underlie, or sustain its phenomena due to precisely tuned organization, precisely tuned in terms of timing, location, and things like this. Whereas in minimal organization, resultant phenomena emerge robustly in ways that are largely independent of this precise tuning of properties or relations between parts. And here again is a homely illustration. The mechanisms responsible for bodily movement in animals are generally nuanced in this sense. The hand's capacity to grasp, or the musculoskeletal system's ability to stand without falling, rely upon specialized and carefully arranged parts and precisely sequenced activities of those parts. But on the other hand, consider the mechanism responsible for creating and dissipating traffic jams at a bottleneck. Traffic jams occur because of constrictions of traffic flow and reach critical points with rapid transition from free-flowing traffic to nearly stopped traffic. These critical points depend upon traffic volume and are little influenced by, for instance, the kinds of cars, the skill of drivers, or even the speed with which the drivers approach the bottleneck. Who or what drives into the traffic jam doesn't much influence the nature of the jam. So this distinction is obviously and intentionally meant to allude to discussions of minimal models, which Bob Batterman has seen as a key to understanding emergence. So Batterman and colleagues see the kind of phenomena described by minimal models, for instance, phase transitions, as being non-mechanistic because such materially disparate systems can exhibit the same kind of behavior, and there can be so much freedom in terms of the organization with these systems, and you still get the same outcome. Minimal models characterize emergent behavior, it is thought, because these global patterns are independent from the details of constituent parts. They point to another feature often associated with emergence, the autonomousness of the emergent phenomena from the emergent space. I am fine with classifying this as a variety of emergence, but I don't see this as at all a question of mechanistic versus non-mechanistic. It simply turns out that some kinds of phenomena are dependent only on minimal sets of parameters, and hence lead to large universality classes, allowing us to see common patterns emerge across quite diverse token mechanisms. So the final dimension of mechanisms that I'd like to discuss is their etiology. Within the literatures, there's been a great deal of emphasis on what mechanisms are, how we find them, describe them, and how mechanistic models explain, but surprisingly little discussion of how mechanisms come to be. And yet mechanisms as composites are composites, and somehow or somewhere they must have been assembled or made. This is most evidently true of biological mechanisms whose historicity and contingency is obvious, but it is also true of physical and chemical systems and their activities. The mechanisms at work in stars depend upon the creation of stars, and the operation of chemical mechanisms requires the proximate availability of appropriate concentrations of molecular constituents. The first type of mechanism etiology that I want to discuss is what I call designed and built mechanisms. This category, which corresponds roughly to the category of allopoietic systems, includes most mechanical systems and processes that are products of human engineering. And the distinguishing mark of these systems and processes is that there is a clear line between their construction and their operation. The mechanism is assembled and maintained by some external agent or agents, and then it does its thing. The car is built by the assembly line, and only then may we exercise its mechanistic capacities for driving. The second type of mechanism etiology is evolution, broadly construed to include not just biological evolution, but any etiological process by which the present state of a system and its capacities and processes has been gradually acquired, and in which there is no clear line between the mechanism being built and beginning to operate. Evolution in this broad sense includes such things as stellar evolution, geological formation, ecosystem succession, and organismal development and growth. There are many distinct kinds of processes by which mechanisms can evolve, so it is appropriate in this sense to speak of the mechanisms of mechanism evolution. First among these are selection mechanisms, where populations of reproducing entities form lineages due to heritable variation in fitness. And there is chance or ephemerality which plays a role, though one might balk at calling that a mechanism. We see this most obviously in the phenomena of drift in biological evolution, but the entrenchment of contingencies in evolving mechanisms is clearly not limited to biological systems. For instance, the current atmospheric mechanisms that account for weather patterns we see on Earth depend deeply on geological, planetary, and astronomical contingencies. Many mechanisms evolve or develop in large part due to self-organization. So this category of mechanism etiology is closely correlated with what I referred to in the earlier slide as affinitive organization. When a mechanism operates via affinitive organization, it is not necessary for an external agent to assemble it. Now, while there are many examples of self-organizing systems in the biological world, they also operate in the physical and chemical world as well. A paradigm of this kind of evolutionary process, for me, are the kinds of evolutionary processes explored by Moreno and his collaborators. Finally, and to anticipate some of what Bill Bechtel will discuss, even in mechanisms whose etiology is evolutionary in this broad sense, pathways of evolution and development may be controlled for by the activity of regulatory or control mechanisms. So, for instance, while the development in an organism is writ large self-organizing, the mechanisms within the organism by which it develops comes about in large part because of regulatory and control systems which shape rates and kinds of growth. I should emphasize that the etiology of a given token or type of mechanism will often be a complicated mix of these stories. Clearly, for instance, the kind of story of the evolution and development of organisms that emerges in the Evo-Devo and Eco-Evo-Devo literature is not one that can be reduced to a single of these categories. Reflection on mechanism etiology shows us that mechanisms emerge in the diachronic sense. So the antecedent materials and conditions that are the basis for the mechanism's formation are its emergent space, and from the process of formation emerge systems and processes that are novel in the sense of being far more than a mere aggregate of those materials and conditions. So let me sum up this section. Both entities and activities may emerge via organized activities and interactions of their components. The operation of mechanisms may produce novel patterns of activity with novel or emergent dynamics. Sometimes these dynamics are only minimally dependent upon the nature and property of the parts. Sometimes the emergent dynamics arise spontaneously via self-organizing entities and activities, and mechanisms themselves emerge as the result of other mechanistic processes, many of which are evolutionary. Okay, last section. My aim in this talk has been to survey some of the many mechanisms of emergence. And the survey was not meant to identify uniform or characteristics of emergent phenomena, but to explore some of the different ways in which a phenomena can be novel or more than the sum of its parts. I haven't uncovered any new kinds of emergence, but I have aimed to show that many of the entities, properties, processes, and patterns that have been called emergent can be shown to be the result of the activities of mechanisms. This explanatory project is reductive in spirit, embracing Wimsatt's principle that emergence and reduction are not opposed. I expect that some philosophers will think that my account of emergence misses the point or the magic of emergence. Emergent phenomena, they might say, must be genuinely novel, and if there are mechanisms that explain supposedly emergent phenomena, then those phenomena aren't actually emergent after all. We may have thought we had something new, but when we found the mechanism, we lost the magic, and we are left with nothing but the activities of the mechanism's parts. To respond to this nothing but worry, let's explore in a bit more detail as it arises in the case of the underlying mechanisms that I discussed earlier. Here we have SSign as a novel activity constituted by the organized phying of the X's. The skeptic will complain that the SSign isn't genuinely emergent because it really is nothing but the X's phying. It is this relation which, following Craver, I am calling mechanistic constitution. Is it a nothing but relation? In one sense, I will say yes. There is no magic ingredient beyond the X's phying, organized, of course, spatially, temporally, and causally. But in another sense, I'll say no. The problem with nothing butism is that it suggests an ontological primacy of the components over the composite. Nothing but sounds like an asymmetric dependence relation, a grounding relation. And it is this sense of ontological primacy which robs the new composite of its reality and its causal powers. There's another way to read the constitution relation, which is to say that SSign just is the organized collection of X's phying. The language of just is suggests identity, which is symmetric. By identifying the SSign with the organized X's phying, one avoids the foundationalist assumption that the component entities and the activities are metaphysically more fundamental or more real than the composite. A common framing of reductionist skepticism about emergent properties originates with Kim's treatment of the causal exclusion problem in the philosophy of mind. So here's a familiar diagram representing the supposed overdetermination of a mental property by a physical supervenience space. Property M supervenes on property P, and P causes on physical property P, and P also causes P star. So while P star covaries with M, the causal sufficiency of P for P star renders M epiphenomenal. The causal exclusion principle, it is claimed, forces us to conclude that mental properties are not causally efficacious. But of course, the very same argument may be applied to any chemical or biological property, given the sufficiency of some hypothesized microphysics. The advantage of identity over realization, of course, is that it eliminates the asymmetrical dependence relation. On an identity account, we may have higher level or lower level descriptions of the same cause, but there are not two causes, one of which can exclude the other. And if we can avoid the supposition that the lower level description is the real description, we may be making progress. But while just is may be progress over nothing but, The emergentist will want something more. How can we give it to them? To return to the theme with which I began, I think it is a matter of taking seriously mechanistic ontology and especially recognizing the importance of time and persistence. Kim's framing of both supervenience and causation is given in terms of disembodied properties. We speak of M supervening on P or P causing P star, where these are properties. Kim does not deny that properties are instantiated and would grant that we can convert this property talk into event talk, where events are particulars, by considering property instances. But it is the properties that are doing the work here. The relation between P and M or P and P star is expressed in terms of metaphysical or nomological necessity between these properties. What is missing from the analysis of the problem is entities or things and their activities and interactions. This is causation process-free. So let's get away from this abstract representation of causal dependence and think for a moment about causal processes in some biological systems. Consider, for example, the life of a cell. A cell is an entity in the mechanist parlance, and at any given instant in time, that cell just is the organized totality of its molecular constituents. But its identity as a cell persists even as those molecular constituents undergo constant change. In fact, the cell could not persist were it not to constantly exchange materials with its environment and transform the materials within it. In this sense, the cell and its life is something over and above any particular set of microstructural constituents. Another problem is that the supervenience picture has gotten totally wrong how macro properties depend upon micro properties. Suppose some soldiers are standing at attention. Their posture is a fixed property at a time, but the persistence and maintenance of this posture over time requires an enormous amount of activity. Standing still and erect is a physiological achievement. To speak of it being realized by a micro property is entirely to miss the causal activities and the compositional relations that make this achievement possible. Much has been made of downward causation as the distinctive mark of emergence, and skeptical reductionists have rejected the emergence of downward causation because it runs afoul of the generality of physics. For myself, I think this whole debate has gone off the rails because it has accepted a certain philosophic framing of what causation is. If we understand causation as a relation, and in particular a relation of nomological dependence between properties, we are going to worry about how the emergent properties are going to be able to act on the base properties. But if we leave that framing aside, but let's leave this framing aside and consider how to think about a paradigm case of top-down causation, the way in which organisms enlist and control their internal processes and construct and maintain their environment. In a multicellular organism, individual cells depend upon larger systems within which they are embedded, and ultimately upon the organism itself to maintain an environment with the resources the cells need to sustain itself and its functions. Cells, for instance, need to take in oxygen and nutrients and to expel waste. Beyond their basic metabolic functions, cells are organized into tissues and organs which allow them to collectively participate within the larger functional economy of the organism. And these in turn allow the organism itself to interact with its environment, for instance, by moving, breathing, or feeding, in ways that provide the organism and then its cellular constituents the conditions required for their continued survival and function. In this utterly unsurprising way, the persistence and activities of the parts depend upon the persistence and activities of the whole. And similar patterns of part upon whole dependence appear at many levels of biological organization. If this is what we mean by top-down causation and emergence, then there can be no denying it about organisms and other biological entities. And in addition to this, it seems to me that many kinds of non-living systems and processes share these features. These are obvious and interesting ways in which the whole is more than the sum of its parts, and what has emerged is not just new properties, but new kinds of entities and activities. A key element in this story is time. While there is a tendency to think about synchronic emergence as occurring at an instant of time, Emergent entities are temporally extended, and to understand why an entity is more than the sum of its parts, you must not look at its organization at an instant, but upon what it depends and upon what it does not depend for its persistence. In this talk, I've hoped to persuade you that there is no real conflict between mechanisms and emergence. If something emerges, there must be some mechanism by which it emerges, and different senses of emergence are connected with different kinds of mechanisms. I also hope to have convinced you that advancing the conversation requires us to abandon some of the favorite philosophical tools for framing the problem of emergence. If we can let go of the tools of analytic metaphysics and turn instead to the tools scientists have developed to represent the dynamics of multi-level complex systems across the physical and life sciences, we will have a much better time understanding emergent phenomena. It is so much easier to understand how and when things emerge when we abandon modal propositional logic and look to dynamical systems theory, network theory, and simulations. Certainly, there remains much to be figured out, but I am confident that no magic will be required. Thank you.